Thermal CVD system is used to synthesize graphene. After hydrogen treatment takes place and the temperature rises to 1000 degrees Celsius, methane is put inside the vacuum chamber to decompose. As a result, a monolayer graphene sheet is formed on the surface of the substrate copper, and flakes of graphene are formed on the opposite side. The backside of the copper, which there are flakes of graphene formed, are taped on an overhead projector film tightly using 3M tape to get ready for a reactive ion etching process. The plasma generator is used for a reactive ion etching process. This will clean the sample surface without any organic material, flakes of graphene, and so on, which will help the copper to dissolve more effectively later on. After the reactive ion etching is done, the edges of the graphene copper sheet, which was covered in tape, is cut out. Then, the graphene copper sheet is placed on top of a thermal release tape with the graphene side facing the TRT and is pressed uniformly using PDMS. Next, the TRT plus graphene plus copper sheet is dipped inside copper etchant and waited until the copper is completely removed. Once the copper is removed with only the TRT plus monolayer graphene remaining, it is rinsed with H2O and put on top of RIE process PET. The PET sheet goes through reactive ion etching in order to make sure any organic material is removed. The sample is then placed on top of an SiO2 wafer and pressed in hot press. Then it is heated for 2 minutes on 150 degrees Celsius heated hot plate. Lastly, the TRT is removed carefully. This method is used only for the first layer of graphene on PET. The wet transfer method, which is used to make the second layer of the graphene on top of the PET sheet, starts off the same as the previous method. The backside of the copper, which there are flakes of graphene formed, are taped on an overhead projector film tightly using 3M tape to get ready for a reactive ion etching process. PMMA solution is dropped all over the surface of the graphene plus copper sheet inside the spin coater and then spin coated with 3000 RPM for 30 seconds. The sample is then baked for 10 minutes on 100 degrees Celsius heated hot plate. The backside's edge, where there is only flakes of graphene, is taped once again to an OHP film tightly, then RIE process takes place to get rid of any organic material or PMMA solution that might have gone under the sample while spin coating. Then, the edges are cut away, and the sample is put inside copper etchant until the copper is removed, leaving only PMMA plus graphene sheet remaining at the end of the process. To ultimately form a bilayer graphene PET sheet, the first layer formed by the dry method is clipped with an SiO2 wafer, while the second layer formed by the wet method is left floating on the water and is picked up like a spoon lifting up, therefore overlapping these two layers. The PMMA on top is then removed using acetone, and the sample is baked for 10 minutes on 120 degrees Celsius heated hot plate. A carbon sheet or a gold sheet was used for more effective transfer of electricity. Copper wire was used so that the electric wire had no direct contact with the nanogenerator and was stuck using silver paste. A thin layer of PDMS was also used on the inside to prevent damage of the graphene while tapping. The two sheets of bilayer graphene PET sheet was taped with one side forming an arch shape. Multiple tapping motions were used to determine the voltage, and the highest voltage was shown up to 4 volts.